Hi, my dear students. We are going to make our mathematics semester 1 important lessons discussion. Here we are going to discuss some important rules that are related to our first semester exam in math. So please watch this and please pay attention to the important rules. They will ease your work. Thank you. The topics covered in mathematics during semester 1 were addition and subtraction of decimal numbers, multiplication and division of decimal numbers, location. We studied the system of axes, the x prime x, the y prime y. We've taken powers and the important rules of powers. Then we have seen the prime numbers, what are prime numbers, and the most important things in prime numbers. Then at last, how we write a natural number as a product of prime factors. If we have a number, how can we write this number as product of prime factors? Now we are going to start each lesson, the important rules of each one. In our first lesson, which is addition and subtraction of integers or decimal numbers, the first case is we are adding two signed numbers. So this is addition of two signed numbers. We ask, what are the signs of the first number and the second number? If we are adding a positive number to a positive number, or we might be adding a negative number, to a negative number. In this case, we are adding numbers that have the same sign. So we add and we keep the sign of the result as it is. So the result have the same sign of the numbers added. So if we are adding a positive number to a positive number, the result will be positive and we add. And if we are adding a negative number to a negative number, it will be negative and we add the digits. As these two examples. We are adding a positive 2 to a positive 3, so the result is positive 5. We are adding a negative 2 to a negative 3, so the answer is, because this is negative and this is negative, the answer is negative, and we add 2 plus 3 is 5. The second case, if we are adding a positive number to a negative number or a negative number to a positive number, in these cases, we look for the sign of the greatest number. If the greatest number is the positive, so the sign is the result is positive and we subtract. If the greatest sign is negative, so the sign is negative and also we subtract. So we use the sign of the greatest number. Now, subtraction of decimal number, we have two signed numbers and in between we have minus. Either we have a positive number, we should subtract a negative number, a positive number, subtract a positive number, a negative number, subtract a negative number, or a negative number, subtract a positive number. In all these cases, we have to add the opposite, which means that the first number stays as it is, the first as it is, change minus into plus, and we find opposite of second number. And here we also return back to addition and we apply the rules of addition. Our second lesson was how we multiply or divide integers. Also in multiplying integers, we have important rules to follow, and in dividing integers, we have important rules to follow. We have in multiplication these four cases. Either we are multiplying a positive with a positive, we are multiplying a negative with a negative. When we are multiplying same signs, always the answer will be positive. So here we have multiplication of same signs. Always the answer is positive. If we are multiplying a positive with a negative or a negative with a positive, in this case we are multiplying different signs, and in both cases the answer is negative. Now, if we are dividing integers, we should follow the following rules. They are similar to the rules of multiplication. If we are dividing a positive over a positive, it might be written in another way: a positive over a positive, or a negative over a negative, a positive over a negative over a positive. When we have the same sign, always the result here will be positive, here the result will be positive, and we divide the numbers, and in this case the result will be negative, the result will be negative, and also we divide the numbers to get the result. In our lesson, which is location, we have been introduced to something called a system of axes. In the system of axes, we will be having two axes. This horizontal line is the axis of abscissa, or the x-axis, and this vertical line is the axis of ordinate, or the y-axis. These two axes form the system of axes. If we can see, or if we look at this system of axes, it's divided, or it divides a plane into 4 quadrants. This is quadrant 1. In quadrant 1, any point belonging to quadrant 1 will have a positive abscissa where it belongs to the x-axis, and a positive ordinate where it belongs to the y-axis. Any point in the second quadrant, which is quadrant 2, will have a negative abscissa and a positive ordinate. If any point belongs to the quadrant 3, or the third quadrant, it will have a negative abscissa and a negative ordinate. To the fourth quadrant, which is quadrant 4, any point in this space or in this quadrant will have a positive abscissa and a negative ordinate. What do we mean by the abscissa or the ordinate? Any point in this system, if we want to locate any point inside this system, it will have something called coordinates. So any point located inside the system will have coordinates. The coordinates is represented by two numbers, the abscissa and the ordinate. The abscissa is the location of the point on the x-axis. So the abscissa where the point belongs on x-axis, and the ordinate where the point belongs to the y-axis. And both axes, the x-axis and the y-axis, they have a positive direction and a negative direction. This is the positive direction of the y-axis and the negative direction. So here we have the origin. We have -1, -2, -3, -4 on the ordinate axis, +1, +2, +3, +4, and on the x-axis we have also positive direction 1, 2, 3, 4, negative direction -1, -2, -3, -4. Any point which belongs to x-axis, suppose this point, which is A, belongs to x-axis, it will have always an ordinate 0. Its ordinate will be 0, and the abscissa is where is A on the x-axis, so A has abscissa -3 and ordinate 0. Suppose that B is a point which belongs to y-axis, so let's find the coordinates of B. Any point belonging to y-axis, it will have an abscissa 0 and an ordinate where it is located on the y-axis. B is 4. In our lesson, which is powers, we have seen that the definition of power is to represent repetition of multiplication. Any repeated multiplication sentence is written in power form. Suppose we have 2 times 2 times 2. This one we call a multiplication sentence. We can write it in power form. What's the number repeated? The number repeated is 2. How many times is 2 repeated? It's repeated 3 times, so we write it 2 to the power 3. Always the power form is a to the power n. When we want to write any multiplication sentence in power form, we should write it in the form of a to the power n, where a is the number repeated and n is the number of repetition of the repeated or the multiplied number. Always in power form, a represents the base and n is the exponent or the power. So a power form, which is a to the power n, means a is multiplied by itself n times. Suppose n is a 3, so we multiply a by itself 3 times. If n is 4, we multiply a by itself 4 times. If we talk about powers of 10 are special cases of powers. Any power having a base 10, if we look at the base and we find a 10, then we call this power as a power of 10. We denote powers of 10 by 10 to the power n. So the base is 10 and the power depends on the numbers of zeros. So when we want to calculate 10 to the power n, it's not necessary to write it anymore as multiplication sentence. We take 1 from the base 10. So we take the 1 and n represents the number of zeros that the one have. So n is the number of zeros. Now we have special rules of powers. We have 1 to the power n is equal to 1. We have a to the power 1 is equal to a. So any number to the power 1 gives me the number itself, and any number to the power 0 always gives me 1. Suppose, for example, we have 5 to the power 0, we directly write 1. We have 10 to the power 0, we directly write 1. Suppose we have 305 to the power 1, it gives me 305 directly because the power is 1. We have very important rules. We use them to calculate powers. If we have a to the power m times a to the power n, this is equal to a to the power m plus n. So if we are multiplying powers of the same bases, the base stays the same and we just add their powers. If we have now a over b, all of it to the power n as a fraction, then this power is for a and also for b. So a is to the power n over b to the power n. Now if we have a to the power m, all of it to the power n, the base stays a and we just multiply the powers together, m times n. Now the last rule of power is if we have a times b to the power n, two numbers multiplied together both to the power n, then this power is first for a and it is second for b. So it's written a to the power n times b to the power n. These are very important rules of powers. They help you too much in calculation and to perform calculations. Don't forget, whenever you have powers in a numerical expression, we should apply rules of order of operations. The rules of order of operation are in this word, which is PEMDAS. As you can remember or will remember, P means parenthesis, E means exponent, M means we multiply, D means we divide, then A means we add, and S means we subtract. So if we want to apply rules of order of operations, the strongest is the parenthesis, then comes the exponent, then we multiply and divide from left, then we add and subtract from left. These are the important rules of order of operations. In our lesson, which is prime numbers, we have seen the definition of prime numbers. So what are prime numbers? Prime numbers are all natural numbers that have exactly two divisors. All the prime numbers or any prime number can only be divided by 1 and itself. If we can take as an example the number 2. What are the divisors of 2? The 2 is divided by 1, it will give me 2, and if we divide 2 by 2, it will give us 1. So the divisors of 2 are 1 and 2, so 2 is a prime number. Let's take 7. 7 is divided by 1, it will give us 7. It cannot be divided by 2, nor by 3, nor by 4, or by 5, or by 6. So it's divided by 7, it will give us 1. So the divisors of 7 are 1 and 7. So 2 and 7 are prime numbers. So these are examples of prime numbers. So we have many examples of prime numbers. We have first a very important note that the two numbers 0 and 1 are nor prime nor composite. So 0 and 1 are two numbers that are not prime nor composite. So 1 is not one of the prime numbers. Examples of prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, etc. The second kind of numbers that we'll talk about today is the composite numbers. Composite numbers have many divisors. For example, if we take the number 6, let's see what are the divisors of 6. 6 is divided by 1, it will give us 6. If we divide 6 by 2, it will give us 3. If we divide 6 by 3, it will give us 2. So the divisors of 6 are 1, 2, 3, 6. Because 6 has many divisors other than 1 and itself, so we call 6 a composite number. So 6 is a composite number. We have so many composite numbers. Now if we have a composite number, we can decompose it, or we can write it as product of prime factors or prime numbers. So any composite number can be written as product of prime factors. This is called prime factorization. How can we do prime factorization? To decompose a natural number into prime factors, we try to divide. We might be able to divide, or we might not be able to divide the number by 2. If we can divide it by 2, we divide it. If we can't, we try by 3, and so on, until we finish our division, or until we arrive to an answer of division which is 1. So when the answer is division finally is 1, so we stop. To do the following prime factorization, we should apply the rules of criteria of divisibility. The rules of criteria of divisibility will help you too much in your prime factorization. So please pay attention to these rules, which you have on your copybooks as a note. I really thank you, my dear students, and I wish you all the best in your semester 1 exams. Okay, thank you.